Hello there, welcome to the 18th video in learning everything we can learn from Apple's documentation on VisionOS. Here we're looking at controlling the transport behavior of a player. Play, pause, and seek through a media presentation. AV Foundation provides comprehensive support for playing media assets, including local and remote file-based media and also media streamed with HTTP live streaming. The framework models its media assets using the AV Assets class, which provides a consistent interface to load and inspect your media, regardless of its type or location. Use an AV Player object to play media assets in the form of AV Player item objects, which models the dynamic state of assets such as its current time. Understanding how to effectively use AV Player is essential for anyone building a custom player UI or otherwise requiring programmatic control of playback. Observe playback readiness. When you create a player item, it starts with a status of AV Player item status unknown, which means the system hasn't attempted to load its media for playback. Only when you associate the item with an AV Player object does the system begin loading an asset's media. To know when the player item is ready for playback, observe the value of its status property. Add this observation before you call the player's replace current item with method. Because associating the player item with a player is the system's cue to load the item's media. Here is a block of code called play media. You can imagine what this function does for us. We're going to play media at this particular URL. Here we have an AV asset from our URL. Here is our player item using this asset and automatically loading asset tracks, duration, and common metadata. Next, we're going to register to observe the status property before associating with player. Player item.publish for status, remove duplicates, receive dispatch queue on main, and we're going to do a sync. With a weak self status in Gartlet self, switch the status for .ready to play, and we're going to present playback UI, otherwise it fails, and we're going to show an error. Lastly, we're going to do a store in subscriptions. And lastly, here we go, set the item as the player's current item. And we do a player.replace current item with player item. When the player item reaches a AV player item status, ready to play status, present or enabled your playback UI. Alternatively, if the failed occurs, show the appropriate status in the player. All right, let's take a look at how we're going to observe playback by looking at the time control status publisher. The time control status publisher observes the time control status to determine whether playback is active or not. What we want to know is a publisher. What does this return? Well, a publisher gives us it's a protocol that gives us a sequence of items over time. So as long as we maintain the life of the publisher inside our player model, we're going to subscribe to it indefinitely. And this is what this function does with all its modifiers. Let's dig into each modifier. Now, let's look at the .receive modifier on dispatch main queue. This particular modifier gives us a publisher receive on this particular scheduler. The scheduler that we have chosen here is the main queue, as we can see here. And we're going to sync. Now, what does sync do? Well, what sync does is that it's going to take received values in a closure so that we can do something with the received values, and then it will return any cancelable. This value we should store. If we do not store, the result would be deallocated and will tear down the subscription stream. Now, the store, what the store does is, as I said, it stores that particular any cancelable value, and we're going to store it into our subscriptions set of any cancellables, as we can see at the top of this particular page, this particular class, player model class. This is that subscriptions in player models. Now, one thing that we have skipped over is the remove duplicates modifier. What this does for us is that it takes the publisher sequence of values and makes sure that we do not get any duplicates. So if we have dot plays 10 times in a row, we're going to get one dot play back. As long as it's not a duplicate, we're not going to do any updates, essentially. So we're just going to get one value and nothing changes. That's what remove duplicates does. Let's take a look at this example to get a clearer understanding. Here we have a stream of numbers 0, 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, and 0. Here we have a publisher to get a stream of these values. Then we're going to remove the duplicates. Afterwards, we'll take the values from each time sequence and pull it in to our sync, which does something with the value. And what we're going to do is print. Here, we're going to print 0, 1, 2, 3, 4 and 0 because we've removed all the duplicates. With that, we have gone over this piece of code. I hope that the understanding is clear. And let's get back to the article. Control the playback rate. A player provides the play and pause methods as its primary means of controlling its playback rates. When a player's item is ready for playback, call the player's play method to request that playback begins at the default rate, which has an initial value of 1.0, the natural rate. By default, a player automatically waits to start playback until it has sufficient media data available to minimize stalling. You can determine whether a player is in a paused, waiting to play, or playing status by observing the time control status value, which we saw earlier. Here we have is playing, and we have observed playing states. We have the publisher for time control status, as we talked about earlier. Dot receive on the main queue. We have a map to set this to be this value that we received to be equal to dot playing or not, whether it's true or not, and we're going to assign it to this particular dot playing value that is published. Observe changes to the rate property by observing notifications of type rate did change notification. Observing this notification is similar to key value observing the rate property, but provides additional information about the reasons for the rate change. Retrieve the reason from the notification user info dictionary using the rate did change reason key constant. Observe changes to playback rate asynchronously. Here we have the function observe rate change async. We're letting the name equal to AV rate did change notification. And then while we await this sequence of information from default.notifications.name, which is the rate did change notifications, we're going to guard for the reason, if there is a reason for this particular change, as the AV player rate did change. Else, we're going to continue. Once we have the reason, we're going to find out, oh, the app went into the background. The app session was interrupted. The set rate called a app set the player's rate or set rate failed. Otherwise, we're going to just break. Let's see if we have this in our code. Looking at our code, we do not have the rate did change notification. Let's take a look at this and see if we can find something more. Let's take a look at notification center.default. Here we have two notification center.defaults, and we're looking for the publisher's AV player item did play to the end of time and interruption notification. Here we have the interruption result, and the result type is that it ended or we should resume, and that determines if we should continue playback if appropriate. Other than that, those are all our observers, and let's move on. Seek through the media timeline. You can seek through a media timeline in several ways using the method AVPlayer and AVPlayerItem. The most common way is to use the player seek_to method, passing in a destination CM time value, and call this method in an asynchronous context. Use a func seek time interval async and set the time to be this particular time interval, and we're going to seek to this particular time. You can call this method a single time to seek to the location, but you can also call it continuously, such as when you use a slider view. The seek_to method is a convenient way to quickly seek through your presentation, but it is tuned for speed rather than precision. This means the actual time to which the player seeks may differ slightly from the time you request. If you need to implement precise seeking behavior, use the seek_to tolerance before and tolerance after method, which lets you indicate tolerance amount of deviation from your target time before and after. For example, if you need to provide sample accurate seeking behavior, specify tolerance values of 0. Await AV player seek time, tolerance before 0, and tolerance after. Let's see if we have this in our. As you can see, we do not use the seek method in our destination video sample code. And with that, completed controlling the transport behavior of a player. Here we learned how to take in information from a player and create our own custom controls for our player. And with that, let's move on to our next article. Here we'll be working on our next article, monitoring playback progress in your app. We'll see that in the next session.